Good afternoon, everyone. Thank you for joining us and welcome to the Washington Statistical Society's 2023 Julius Shiskin Award Seminar. My name is Catherine Iramata, and I'm the current WSS Methodology Program Chair, and I'm chairing today's award presentation and seminar. I'm pleased to introduce our 2023 Julius Shiskin Award winner, Dr. Dennis Fixler, as well as the chair of the Shiskin Award Committee, Dr. Marshall Reinsdorf, who are here with us today. I'm going to introduce Dennis and Marshall, and then I'm going to turn it over to Marshall, who will be speaking about Dennis's accomplishments and his selection for the award, as well as give some background on today's presentation. So first, Dennis. So Dennis Fixler is the Chief Economist of the Bureau of Economic Analysis and is primarily responsible for statistical quality, methodology, and lead selected research efforts. His research is in the area of economic measurement with a current emphasis on the distribution of income and environmental economic accounting. He served as a member of several international committees writing manuals on price indexes and indicators, and has been a long-standing member of the UN committee writing the suite of manuals that form the system of environmental economic accounts. His research has appeared in journals such as Economica, Journal of Productivity Analysis, European Economic Review, Economic Inquiry, Review of Income and Wealth, and American Economic Association Papers and Proceedings. I'll also introduce Marshall. So Marshall Reinsdorf has been researching and writing about measuring the economy since he joined the Bureau of Labor Statistics as a research economist in 1986. He was later chief of the National Economic Accounts Research Group at the Bureau of Economic Analysis and a senior economist in the Statistics Department of the International Monetary Fund. He served as president of the International Association for Research in Income and Wealth from 2018 to 2020. And in 2021, he received the Shiskin Award for work that he did at BLS and BEA. He has published extensively on measuring prices, output, productivity, real income, and other topics, and is currently a chapter editor of the forthcoming 2025 System of National Accounts and the co-editor of a forthcoming book titled The Measure of the Economy. His PhD in economics is from the University of Maryland. So we are very honored to have both Dennis and Marshall here today. And Marshall, I'll now turn it over to you to talk more about the award.
Thank you, Catherine, for leading it off. I'm assuming everyone can hear me. Good. Well, it's an honor to be able to be here and introduce Dennis, a longstanding colleague, for his Shiskin Award speech. Let me give two pieces of background for this talk. One, I'd like to say a little bit about what Dennis is Fixler at the Shiskin Award, and what Dennis was recognized for. So the Shiskin Award, Dennis has a long and distinguished career, but we picked three things really that drove the selection of the award. First, there was a lot of innovative work on the measurement of financial intermediation, which became part of the background for how we improved the measurement of financial activity in the national accounts and in the producer price index. And second, there was this measurement of property casualty insurance, which wasn't working so well when there was big disasters, and Dennis's research helped to really solve that problem. And the third thing we were thinking about was his leadership in the developing work on the distribution of personal income. So those are just a few of the highlights that were mentioned in his award. Let me also give a background now on the two topics, distributional and environmental accounts. We are moving in the system of national accounts, the next, which are the guidelines for the basically worldwide guidelines for preparing national accounts, to putting much more emphasis on including some distributional informations. That will be part of the core requirements. And also a lot more emphasis on the links with the system of environmental accounts, which Dennis has worked in extensively and is an expert in. So these are both very timely topics, because I'm personally wondering how BEA is going to do at keeping up with all the new demands that are supposed to come out next year. But with all that, I guess I will turn it over to Dennis, and I'll be very interested to hear his talk. Thank you.
Thank you, Marshall. It's a pleasure to be here. It's an honor to be here to talk about my work, and of course, it's an honor to have received the award. So Marshall gave some background to the two topics today. So they're very important in an international framework. They're receiving a lot of attention, and BEA has made some interesting inroads in incorporating them. So I'm going to talk about these two accounts from measurement perspective, and I'm going to put it in terms of theory and implementation. And the idea here is that we have to think about how we're going to do this in a way that is going to satisfy the users of the national accounts. So when we think about theory, I mean, one way I'd like to think about it is we think about the set of questions that we want the measure to answer. So what should those be here? What do we want an income distribution in the national accounts to be able to say about inequality or environmental impact? These are very topical issues, and people have different needs and have a different set of questions. So we have to be a little bit more specific if we're going to pick the right measure. And then once we decide what components should be of the measure, these are complicated accounts. And so what are we going to look at from the theory point of view? What should the measure contain? And what's the theory underlying the formation of the measure? And then should we look at just top line numbers, or should we go into the details and look at some of the finer details to comprise the measure? And once we've done all that, we have to talk about implementation. So, okay, you pick your variables. Now, what do I actually have that corresponds to the theoretical variables? What kind of proxies can I come up with or derive? And then ultimately, what data should be used? So one way of thinking about it, I think, is like in this Venn diagram here. We have theory, we have implementation, and if we're going to produce estimates, then we want the overlap. We want the intersection of these two sets here. Hopefully it's bigger than the one I put on the screen, but that's sort of the way I think that we look at producing estimates. So I'm going to start with income distribution. Simon Kuznets was one of the founders of the U.S. National Accounts, and from the very beginning, he thought that income distribution was important to the accounts. So in order to get a comprehensive picture of the economy. So in macro, in national accounting, you can measure GDP, the top line number of the output produced in the economy for a period. And then you could say, okay, I can measure it by all the expenditures on goods and services, or I can measure it by all the incomes received by the people who produce all the goods and services, or all the agents that produce the services. In principle, they should be the same. In practice, it doesn't work out that way because of the source data that we receive, the different timing of the source data that we receive, and there are some different measurement issues that prevent the equality. So the income distribution of households or individuals, that's another decision that has to be made, provide insight on who's benefiting from GDP growth. And that was really the fundamental question formulated by Kuznets. It's a major question. If you look at the literature on economic development, countries have different stages of production, growth. So what's the relationship between economic growth and income inequality? And I'll talk about that in a minute, Mr. Kuznets' theory about that. And until the mid-1960s, BEA produced a distribution of personal income. And at that time, it was given up for resource constraints. And there wasn't any provided. And then in 2014, David Johnson, who was at BEA at the time, and I started working on trying to bring it back. And so the first paper that talked about how this might be done was this NBER paper that was presented at a conference of Review of Income and Wealth at NBER. And since that time, the work has evolved, and there are many more references and a lot more people at BEA involved in it. And instead of listing all of them and putting on a slide, if you go to the link to the landing page for the distribution of income, you can find all the reference papers that have subsequently been written and the people that have been involved. So a lot of people have different ideas about the relationship between economic growth and income inequality. And Mr. Kuznets had one too. So in a very famous paper in the American Economic Review in 1955, he proposed this inverted U-curve, which means that in underdeveloped countries, as they developed or incomes are low, inequality should rise. And then at some point, it should turn around and income inequality should fall as the economies progress. And this has been extensively examined. I picked one article that really did a thorough review of the evidence. The evidence is mixed, but this paper goes into all the different factors other than economics that may affect the income, the inequality trend. And so he talks about institutions and so on. So it's a really interesting idea here that as countries get wealthier, the level of inequality should fall. But if we're going to do that, then the fundamental question that comes around is, what's the concept of income that should be used for an inequality measure that fits into this kind of discussion? And that's where we started our discussion, David and I, when we started putting this together, because the idea here is if you look out into the statistical system, there are measures of income that are used quite a bit, and there are discussions of distribution of income. So the Census Bureau produces a measure of money income, and I put the definition here on the screen: regular basis before payment and taxes, includes government transfers. The Congressional Budget Office has a market income concept, a little bit different. Notice it's before government transfers and taxes. The IRS has distribution, and of course that's on tax income. And then there is a lot of academic research, and they use national income. So the first three are not explicitly related to GDP. National income is. And so one of the fundamental questions that we wanted to answer is that if we're going to talk about economic growth, which is measured in the growth rate of GDP, then you need a concept of income that corresponds to that measure of growth. Otherwise, you can't really talk about how growth varies and income varies if there isn't an alignment or a consistency in the accounting. So there are two possible measures: national income and personal income. And as I said, a lot of the academic researchers use national income. And we decided to distribute personal income. And the reason is it's the income concept that goes for decision-making, specifically consumption. And secondly, macro models of the economy use disposable personal income in the modeled consumption function. So we thought it was pretty natural to pick personal income. And just for some national accounting background here, personal income is the income received by persons. They get this from participating in production. It includes government and business transfers. It includes the service flows from home ownership and holding interest-bearing securities and corporate stocks. It's the greatest component of gross domestic income, the income counterpart of GDP. It's closest to the measure of economic resources available to households to purchase goods and services. And as I said, after-tax personal income is the major explanatory for personal consumption expenditures, which is the major component of the expenditure approach to GDP. Academic research, largely Piketty, Sias, and Zuckman, have promoted national income as the way to measure the wealth or the income received. And so, and a lot of subsequent studies have used it as well. So just to give an idea here, personal income is related to national income. And you can see it's national income minus a lot of factors like corporate profits, taxes on production, net interest. And these are very common or prominent parts of the national accounts. But the last bullet here, you have to distribute these. And so when it comes to corporate profits, dividends are already included. Well, how are you going to distribute, for example, the undistributed part of corporate profits? So PI is the sum of many components. These are national totals. And if you go to the NIPA table and the BEA website table 2.1, you could see the long list of the components that we add up to get to personal income. Now, I thought I would show, okay, so you picking these two concepts, does it really make a difference, and how much of a difference does it make? So they're very compatible in size. The difference is a few $100 billion. GDI, the gross domestic income, the top line is considerably larger. But if you look at the bottom two lines, this is the difference between national income and personal income. Notice that the trends pretty much are the same. Now, when people argue for national income, it's interestingly enough, they usually argue from the point of view that national income is larger and therefore it's a more inclusive measure of income. It captures more of the income that should be distributed. And if you look at this graph here, you can see, well, that's true sometimes, but it isn't true towards the later years here, 2020, and so on. And the reason is transfers. Transfers are not part of national income, the computation of national income. They are included in personal income. So 2020, the COVID pandemic and all the transfer payments that the government issued drastically changed the relationship between national income and personal income. So I've mentioned this concept quite a bit. The personal income is an aggregate and there's no distribution. Okay, so then distributed to who? So we could talk about households, or we could talk about individuals. And then once deciding that, what's going to be used for the basis of the distribution? So there is no distribution for PI. It's an aggregate number, come up from that, all the adding up of 2-1. No distribution, so we have to come up with something to base it on. So we picked households. We thought that that's the way economics usually talks about the units in the economy. So we picked the households as the statistical unit. And then we decided to use the current population survey from the census for the distribution of households. That's fine, except that CPS top codes. And so the upper tail isn't as revealed as as the lower income classes. And so we had to figure out something to do. We don't have access at BEA to the micro tax data. So we had to use the IRS, or more specifically, the statistics of income public tables to approximate the top tail. And then aside from the tax data, there's a whole bunch of other source data that I'll show you in a minute that we had to look at, looking at time lag, extrapolation. We've adopted some machine learning techniques to incorporate some of estimate some of the distributions, the allocations. And the last bullet is the key here. We have to design an allocation algorithm for each source of data. So if we pick something, let's say dividends, how do we allocate it to households? we have interest income, how do we allocate it to households? We get a top line number of wages. How are we going to allocate it to households? So the problem was the extent of the underreporting in the CPS differs by income source and income group. And so there were more measurement challenges here. And then survey changes. So had to worry about consistency of variable definitions over time. So to give an idea of the various source data that we use here to produce the distribution of income, I thought I'd include this graphic here. Now, I should point out, BEA does not collect really any source data aside from the international transactions accounts, which are largely from BEA surveys. So it's only in an international area, and that only amounts to about 20% of our source data needs. So looking at this chart here, we have the consumer, the current population survey, the IRS data, survey of consumer finances, which comes from the Federal Reserve, the American Community Service, Census Bureau, Consumer Expenditure Surveys, BLS, and because of the importance of healthcare, the Medical Expenditure Panel Survey from AHRQ. But the key is the CPS, the annual supplement. Now, if you look at the little table on the side here, these are all great sources of data, but look at the lags. IRS data we only get with a 2-year lag. The CPS is a 1-year lag. MEPS is a 2-year lag. So making this current is also challenging. So we constructed a distribution of personal income from publicly available data. And I put the links here for the technical document and the working paper on the BEA landing page to give you the details. So there's 60 components of personal income. We identify the CPS variable and the outside variable to allocate the components. And then we sort of divided personal income into categories, the adjusted money income, which corresponds to the census income variable. We added some financial variables, imputed interest, healthcare, Medicare using CPS, and Medicaid using the machine learning algorithm that we came up with. Other transfers, the WIC, CPS, SNAP. And so household income is the sum of the four, excuse me. And then personal income is household income minus household current transfer receipts from nonprofits, nonprofit institution transfer receipts from households, and nonprofit institution income. So the last component is important because personal income includes the category in the national accounts, nonprofit institutions serving households. And so if we wanted to focus on households, we had to get rid of this nonprofit institution income. And the last bullet, the equivalizing the households, is to take into account the fact that households are of different size. And so what we want to do is to make sure that we're comparing, we take into account household size when we're forming this distribution. So simply, we use the square root of the household size. OECD, for example, has a weighted average, but the idea is quite intuitive. If I have two households and they each earn $1,000, and the first household is just a single person, and the second household is a family of 4, I can't say both households earn the same income. I mean, it just doesn't make sense. So dividing by the square root of n means the second household really has an income of 500. The first household, the sole member, has an income of 1,000. So taking into account household size does make a difference in terms of what are you going to say is the household income. We present a variety of inequality metrics, deciles of both personal income, disposable income, top 1%, 5%, bottom 5%, Gini, 90-10 ratios, 80-10 ratios. All these data can be found on the landing page, and you can download as a flat file. They're individual year spreadsheets. You can do a lot of different things if you're interested in creating a series here. For those of you unfamiliar, the Gini coefficient, the very old idea here, it's an aggregate that gives you it goes from 0 to 1, where 1 means that it's completely unequal, and 0 is completely equal. So let's go back to the Kuznets curve here. And so what do our data show here about what I consider to be the only relevant sense for the United States, the downward sloping section. We're a pretty developed economy. So looking at it should be that we should see a downward trend in inequality. And what we see here is a lot of ups and downs, but basically, aside from 2020 and 2009, it's fairly stable. Not moved out a lot. You do have some dips, but you have some ups and downs, and the movement isn't that great. Notice on the right-hand side of the scale, it's pretty fine. So the optical may look like there's more movement than really there is. So, can't say no. I wouldn't say there's a clear downward trend, and the upward trend line is GDP. So let's look at some other pictures here. So real, inflation adjusted personal income and disposable personal income grew 32% in this time period on the graphs, and the medians grew by 29%. Okay, so the mean and median growth usually are different if there's some kind of unequal distribution. So if you look at the right-hand side graph, this is the equivalized disposable personal income. It looks a lot like the graph I just showed you for the nominal Gini. And so taxes really don't do much here in terms of changing the distribution. To my point about stability, if you look at the graph on the left, you see that if I look at the bottom 40, the 40 to 80, and the top 20, they're pretty flat. Not a lot of movement there. And so that also would argue for stability in the distribution. Notice the Gini fell by a very small amount over the period, despite the business cycle volatility. Now, I mentioned that there were some other concepts of income, so I thought that we'll look at some from the literature. So I have national income. I have national income on here, as it's represented by the Otten-Splinter approach. Otten and Splinter are two researchers that really focused on the Piketty-Saez work, and they found some what they talk about as errors in the treatment of tax changes. The BEA disposable income approach and the Congressional Budget Office. And if you see here, and if you look here, you basically see that they pretty much are close together, differences in levels, but certainly BEA and the Otten-Splinter, the national income approach adjusted for Otten-Splinter's tax adjustments, are pretty close together. So it makes a difference. Because look at the CBO one after transfers, but they trend pretty much the same. Now, Marshall mentioned the topicality internationally, and international comparability is extremely important. And if you think back to the Kuznets curve, you can think about it within a country, as the country develops, what should happen to inequality. But across countries, you can think of, okay, well, as countries develop, as we go from less developed countries to more developed countries, what do we observe about income inequality? And in order to do that, the income has to be measured on the same basis across countries as the level of GDP. And this is the function of the manual that Marshall talks about that was being rewritten here, the system of national accounts. And one of the international organizations that has had a substantial effort, excuse me, that BEA participates in is the OECD for trying to standardize the treatment of income, of measuring income for inequality measurement across countries. So they use a concept of adjustable disposable income, slightly different, but you can see here on the graph here, comparing the Gini's, is pretty much a level effect with the disposable personal income being close to the OECD measure. The main difference is that in the OECD, your S&A view, there's a larger treatment of what's called the transactions in kind, subsidies, transactions in kind. And so education expenses are treated differently, healthcare expenditures are treated differently. And so that's one of the sources for the difference. Now I'd like to turn the attention to the environmental accounts. And the way we decided to do this, it was because of the way we started to do environmental accounts, is we're focusing on land. And we do that because, you know, land has been a factor in the production functions for a very long time in economics. And I put this quote on from Alfred Marshall, one of the premier marginalist economists, and at the turn of the century really helped fashion economics the way it is now. And notice that he treats land here as sort of an indicator for nature, period. Water, air, light, heat. And so land meant natural resources, and we sort of went with that idea and focused on land first and foremost, as I'll show you. Again, here, the main concern is we have this economic growth, fortunately. And so what are the implications for the use of natural resources? More specifically, have the environmental cost of growth been fully accounted for? And it's a measurement challenge in the following way. For many expenditure categories in GDP, we can observe prices and infer quantities by deflation, dividing the expenditure that we see, the revenue we receive, and dividing it by the price index to infer a quantity. And even in cases where we observe quantities, like automobiles, we still do the deflation approach, because how are you going to add up this many Volkswagens, this many Chevrolets, this many Buicks, and so on? And the way to do that, of course, is by putting everything in dollar terms. And then in order to get the implicit quantity, we divide by the price index. So we need prices, and we get quantities secondary. For natural capital, land, the problem is reversed, so to speak. We observe land, we observe water, we observe forests, but how do we value them? And in many cases, we're dealing with assets, goods and services that are not traded in the market for a lot of cases. So it makes it even harder to come up with the corresponding price. So how do we think about the relationship? Well, you know, Kuznets was a very popular guy, and people took his income inequality curve and said, well, you know, that might apply to the way environmental works with the economy. So there is this environmental Kuznets curve where you have pollution. One is a stand-in for all sorts of environmental costs and how that moves with income, GDP. And so beyond some point, the economy should have the capacity to pay for mitigation. So the economy could get rid of the pollution, and technological change would produce less pollution. So two things could be going on. Here again, no consensus on its validity. This is out there. And so here's an article by Distributional in the Journal of Economic Perspectives, confronting the environmental Kuznets curve and all the factors that might indicate why it doesn't really happen. The position of this paper was it's not a valid, it's not valid. So from our perspective here, the role of the environment and the economy is, of course, more than just pollution of natural resources. There's assets, goods, and services, and these have to be accounted for if we're going to produce environmental accounts. So we want to measure environmental goods, services, of assets, and assets in the context of the economy. So BEA did this in 1992, 1994. There were two articles in the April 1994 Survey of Current Business, the Integrated Environmental Economic Satellite Accounts. And the US work was suspended because our attempt to do that was not well received by some members of Congress. They told us not to do it anymore. And one thing that they did say is that, well, we should have this National Academy of Sciences study about how to do environmental accounts. And so the reference there to the Nordhaus Cocklenberg book, Nature's Numbers, which was received a lot of attention, was commissioned, and it has a lot of interesting ideas that subsequently have been applied. So since that time, and part of the work that was done earlier on, so statistical standard manuals have been addressed, developed. 2010, 2012, the System of Environmental Accounts, the SEIA Central Framework, and 2021, System of Environmental Economic Accounting, Ecosystems Accounts. So notice these are two different perspectives on how one should do environmental economic accounting. The central framework is the basic goods and services, assets, similar to the national accounts. The ecosystems account takes a more integrated view of the environment. So the ecosystems has provisioning services, recreation services, all sorts of things that you get from an ecosystem asset. Different perspective than the basic national accounting. We are, as I'll point out, we're focusing on the central framework. And then last year, there was this interagency U.S. Natural Capital Accounting Working Group that was put together, started by the Office of Science and Technology in the White House. And there's a paper here for a BEA researcher participated in this ecosystem services and piloted land and water and ecosystem accounts. So our plan is to use the SEIA Central Framework-based pilot estimates of environmental activity to U.S. economy. We're going to focus on the Central Framework, Chapter 3, Physical Account Flows, and then environmental activity accounts, Chapters 4, environmental protection, expenditure accounts, environmental goods and service sector accounts, and taxes and subsidy accounts, and environmental asset accounts. And our first effort is going to be on environmental goods and services. And that's where we've paid the most attention recently. So like all goods and services, what we need here is a classification system. And in the SEIA, there are some definitions here. So Europeans are far more along in the development of environmental economic accounts. So we took some of their systems, I used an acronyms here, the CPA, the CIPA and CREMA, and you could see the definitions below, to come up with a classification system that corresponds to the US the product classification system and the North American industrial classification system. And even when we did that, it's hard. So there are some categories that were fully, we can easily say everything is 100% environmental. But there are a lot of 2-4s. There's a lot that only are partially relevant. So not all of it is environmental. And then there were some that were just out of bounds. I mean, there's nothing that corresponds. And so the first two were sorted by these European-based classification systems. And I'm going to show you some charts that were in this paper that was from a conference earlier, and it shows some estimates of how we would treat the environmental accounts. So last year, I think the conference, we produced a paper in July, but I think the conference was actually in March of 2023. So here's a pie chart from that paper. And what's important to see here is waste management, wastewater management, management of water, and heat and light. So a lot of management activities, managing the environment. This is the case where no partial category. So this is the ones where it was 100%. We can actually look at this and say it's 100% environmental. In the paper, we went through the scenario of where there was a partial overlap, and we just arbitrarily picked 10% as the value of the overlap and carried on the analysis from there. So I decided it's more, it's clear here if I just pick where there is no partial. So one of the interesting features here is we looked at, well, what's the difference between private sector and public sector? And as you can see here, it's largely private sector. And what was interesting in these 4 years here, there's almost no change in the share of activities, the shares of the public and private sectors. And then we provided some detail here. So if you look here at the industries underlying that private public split here, you could see, for example, waste management, the third from the left, you could see how it's almost entirely private. And what's interesting, I thought, is that the blue areas, the public, they're only in about 4 industries. And other than that, they're very small amounts. So you could see here why the orange part of the chart is so large. So the main result is that if I look at environmental goods and services, the gross output was $725 billion in 2019, a lot of money. 1.9% of total gross output in the U.S. economy. The public sector split is 28%. And $738 billion when a portion of the partial categories are included. I didn't show you that result, but that was the second scenario that's in the paper. So if we look at what's most important for environmental goods and services in the U.S. economy, it's waste management, wastewater management, and water management, which was kind of surprising. So what are we going to do with these? BEA has a system of satellite accounts. I guess Marshall can explain they're no longer going to be called satellite accounts. One of the aspects of the new manual is that they're going to be called thematic accounts. So these are supplement primary estimates. And you could see here on the graphic, we have an outdoor recreation account, travel and tourism, healthcare, arts and culture, marine economy. We get the data from, our current source data providers. So you could look at, I think the way to look at these is 2 ways. One, they provide a way of experimenting, forming accounts, and we encourage users to comment on them, and they evolve. Second, they take data and present it in ways that are not included in the official account. So travel and tourism, I think, is probably the best example of the second case. And sometimes the satellite account, when it receives a lot of attention and we think we've refined it, we may bring it into the national accounts. And that's what happened with the research and development satellite account. which went through several iterations, but in 2013, we decided to move it into the core accounts. So it goes. It's just a useful way of providing estimates for people to look at. For the case of environmental, we're going to be using the economic census and other sources, and again, USDA, Department of Energy, Department of the Interior. And notice that we have 5,300 product categories. I mentioned assets. Land and other natural capital assets are not currently itemized in the U.S. balance sheet, but they are in the system of national accounts. And that category is that AN2, non-produced, non-financial assets. And you could see the entry right underneath here, AN21, natural resources. So one of the things we need to do here is if we're going to, since all assets in the national accounts are put in dollar terms, then we have to come up with a way with valuing the natural assets. So here again, we looked at land, and the plan was we had to go out and get data here. So we got Zillow data, and soon we're going to get the Black Knight data, look at transaction level data. So the idea here is to look at Zillow data. This is for the household sector largely, and look at the value of land and household transactions. So we used a hedonic regression approach in 2020, first iteration, then a machine learning approach in 2023. The quantifying of land, there's a national land use database, combines data from the U.S. Geological Service, the U.S. Department of Agriculture, Census, NOAA. It was only produced in 2010, so we had to change to, we will change to this land change monitoring assessment and projection. There's a paper here that I put the link to from a couple members of my staff here about using measuring the value of land. And look at the size of the numbers here. If I put in the total value of land, residential, commercial, industrial, and agriculture, huge numbers of the value of land. So not surprisingly, land is a very important asset, and clearly it's going to make an impact on household, on balance sheets for the economy. And not surprisingly, it varies by location. The value of land varies by location. So you could see here that it's a little bit faint here, but the Pacific area is the top line, and so land values are very high there. If I look at the South, and much lower here, so not surprising, real estate markets pretty much this is in line with real estate markets across the country. So my purpose here, I say I'm coming on time here. So my purpose here was to just give you some brief outline of how extending the national accounts to include distributional and environmental information to enhance the picture of the economic performance, and to show that we have to find this overlap between theoretical measures and implementable measures, and doing so, it's more art than science, and that's why we encourage users to comment on what we're doing. But if you think about the set of questions I talked about, for both income distribution and environmental accounts, single measures are unlikely to satisfy all the needs of users. Okay, so this is one of our problems here. People look for all sorts of different things, and then they'll say, but can I use this number to answer this question, and say, no, it doesn't do that. Or why don't you produce a number that I could use for this purpose? So especially in the environment, discussions about climate change and all sorts of things, it's very difficult to take a single set of measures and apply to address all the issues that one might think of, the impacts of climate change. And because there are so many decisions along the way, that users need to bear in mind that there's uncertainty in these estimates. Not uncertainty necessarily in terms of if I took it if all the data came from a survey, and I'm talking about survey error and sampling error and distribution, the mean and the variance. It's even beyond a total survey error concept. That there are just uncertainty in the measures and all sorts of ways that uncertainty could enter the estimates. And so from my perspective here, this is a fundamental question here: is there a role of interval estimates? So for example, if someone comes up with we're doing the environmental account, and we have to make these decisions about the value of let's say a forest. We do it under one set of assumptions. Somebody might say, well, I think that it should be not these assumptions, but these assumptions. Well, it could be true. And so one way around this is we just provide an interval of estimates. We pick some assumptions, carry through, and then users can pick which one they want. So that's my talk for today. Again, I'm happy I had the opportunity to do this, and I'll be happy to answer any questions in the remaining time.
Thank you so much, Dennis. So we do have time for questions. So if there's any questions, you can enter them into the chat, or you can raise your hand to be unmuted. And while we're waiting, Dennis, I had a question. So
Sure.
I'm not an economist. I'm probably not using the right words, but I do think this is a very complex problem, turning these theoretical measures into something that you can actually implement. And there are a lot of decision-making and assumptions that need to be made. And I'm wondering what type of sensitivity analyses go into, you talked about some of the various decisions that need to be made at each stage. And so what does that look like as you're thinking about the different assumptions?
So, I mentioned the last part about the environmental goods and services where we had to draw these lines here for classification. So that would be an example of where we're looking at. So the paper that I referred to had a 10% overlap. So when the data aren't good enough to tell you how much of the total revenue or expenditure is going to environmental and how much is going to non-environmental. So we picked 10%. So it's that kind of thing. You pick one, you look what happens. So what's the response if we change the percentages? So the last slide I showed, not that great a difference if I include that section and put the 10%. But 10% is not a lot. So but we don't have a formal procedure where everything we do, we go through and do a robustness test and see what happens.
Yeah, thanks. Yeah, very interesting. And I learned a lot because this is really not my area. Any questions from the audience? I saw some clapping. Thank you very much.
Yes, thank you. I think I see something in the chat.
Let's see.
Is that just on my screen or do you see it too?
No, I see it. Congratulations, Dennis.
Okay.
Yes.
It's from me, Dennis. It's Bonnie Murphy.
Oh, hi, Bonnie. Thank you.
You deserve it.
Thank you.
Vincent, yes.
Hi, congratulations, congratulations, Dennis.
Thank you.
So I'm thinking about classifications as you're going through this, as
Yes.
you can imagine.
I wonder why.
Yeah. And I noticed there was quite a bit about environmental protection, environmental management. I wonder about remediation activity and if you're picking up, I'm thinking things like carbon capture and storage, and there's increasing amounts of that going on. And is that reflected? How well is that reflected, or can we do better with that?
Well, I think internationally, everybody's looking at two classes of expenditures that go for mitigation expenditures and adaptation expenditures. So I would consider carbon capture sort of a mitigation type of expenditure. And so those two classes are receiving a lot of attention. But there's been no fine, at least to my knowledge, there's been no fine line here about going, okay, well, we want costs of mitigation. Let's say, what are we going to include under that? And you could sort of imagine in, okay, carbon capture. I have equipment at the end of smokestacks for air pollution. Is any of them carbon capture? If I grow a forest, does that count as carbon capture?
Yeah.
I mean, so these are the kind of judgments that, where are you going to draw the line here? So ECPC, you should, this is.
Yeah. Thank you and congratulations again.
Thank you. Thank you.
Any other questions from the audience? All right. Well, Dennis, thank you so much again for giving the presentation, and congratulations again on the Shiskin Award.
Well, thank you for both. Thank you on both accounts.
Yes, no, we're so glad you could be here. And thank you to our audience for your participation and for being here and celebrating the award. I put in the chat the link for the WSS website as well as our YouTube channel. So today's talk was recorded and it'll be posted on the YouTube channel, so you can access it there. Our next methodology event is scheduled for May 16th. It'll be a memorial seminar for Carol Blumberg. And so we'll have an announcement going out on that next week. So thank you all for attending and have a great rest of your day.
Yeah,
All right.
thank you.
Yeah, congratulations, Dennis.
Thank
Yeah.
you.
Very good work. Thank you.
Thank-
Bye.
Bye.